Hi everyone, my name is Elif and I'm a PhD student here at Sorbonne University in Leipzig. And today I will briefly talk about my PhD subject, which is about resource allocation in Metaverse. We are a team of 5 people working on this subject and we are funded by Nokia. Um, So to start with, what is Metaverse? Metaverse is a shared virtual and collective virtual space that bridges the physical world and the digital world. And in this metaverse, users can interact with each other and with the digital environment in almost real time. And you can think about it as a multiplayer virtual reality game where every move you do in the physical environment needs to be reflected in the digital environment as well, and it needs to be reflected quickly. And also, you can think about it as a digital twin of a smart city, as in our case. So as you can see, this setup can create a massive stream of data that is constantly flowing between user devices, mobile devices, sensors, and their digital counterparts. And so to be able to achieve this metaverse, we need a smooth and immersive experience. And to do that, we need high-speed communication, low-latency edge computing, and the real-time synchronization. If we cannot achieve this, then the user can feel the latency, and they can feel the outdated data, and at the end, eventually, their experience will fall apart. So what we introduce as a solution is MetaLore, which is a learning-based resource allocator in Metaverse. We try to jointly optimize the communication and the computational resources. We propose a framework that learns dynamically and optimally how to split the bandwidth and the computing resources among 2 different kinds of data streams. The first one is the user-generated service request, and the second one is the sensor-generated environmental updates. And here, our goal is again to enhance the synchronization accuracy, to reduce the end-to-end service delay, and overall maximize the system throughput. In our work, what is our key contributions? First of all, we propose a multi-objective optimization problem, which our aim is to optimize the service end-to-end service latency, the synchronization accuracy, and system throughput. And to do that, we propose 2 new age of information metrics. The first one is the age of request information that captures the time of the time that is passed between the generation of user request and the serving of this request. We also propose another metric called age of sensor information, which captures the freshness of the data. And to train this model, we use deep reinforcement learning techniques and specifically PPO algorithm. And with these new 2 metrics, we shape our reward function to train our agent in the environment that we built. And lastly, we built a custom simulation environment that we extended from a previously coded mobile env simulator. And as results, we see that the model that we train matches the brute force solutions, the grid search solutions, and in most of the cases, our model outperforms the brute force solutions. And another important thing that our model adds is that we can adapt the split of the resources on the fly according to the changing conditions in the network and the traffic. As next steps, we want to do other model trainings, and also we want to use multi-agent reinforcement learning and maybe transfer learning. We also want to scale up our environment to a multi-base station environment, which across different sub-metaverses can be interconnected. But this will also create more problems that we have to deal with. For example, inter-base station synchronization, resource sharing, and device association. So thank you for listening to me, and I'll be happy to answer your questions in the poster session.